In this video, we're going to be looking at how to assess whether a graph is normal or not in a couple of different ways. So the first way we learned is what we learned in class, which is if we're given a set of data, then we can look at the histogram and see what the shape of the histogram is. So in order to do that, we need a set of data. So I've given you 36 pieces of data that represent the capacity, the usable capacity of a side-by-side, of 36 side-by-side refrigerators. Now, the quickest and easiest way for us to determine if this graph is normal by doing a histogram is to use the calculator and let the calculator draw the histogram for you. So if you take out your calculator and turn it on, hit the STAT button, the stat button, and then hit enter. In list 1, you want to go ahead and put in all 36 pieces of data. Now you can see that I have already done that for you on the video. So what I want you to do is pause the video, go ahead and enter this data into your calculator, and then once you have it entered, restart the video. Okay, great. Now that you have all of the data entered in, we want to let the calculator draw the histogram so we can see if the graph is normal. So go ahead and hit your blue button, which is your second button, and then the mode button, which will quit you out of the list, and then clear the home screen. All right, let's review for a minute how to have your calculator draw the histogram. To do that, we need to get into the stat plot. So we're going to hit second y equals, and we notice that on my calculator, all of my graphs are turned off. Yours might have one on and the rest off, or they might have more than one on. The way that you want to have your calculator set up when you do these type of graphs is you want the first graph to say on, and the rest of the graphs to say off. Since this one's off, we have to turn it on by hitting enter, hitting the right arrow key, and hitting enter again. Now, if we were to go back into the stat plot, we could see that the first graph is now on and the rest are turned off. All right, we want a histogram. The way you get the histogram is you arrow down one time and to the right twice, and you'll see that's the histogram. Now mine's already set for a histogram. If yours is not, go ahead and hit enter. Down on the next line, so if you hit your down arrow key another time, you'll get down to the X list. Now remember, we put our data in list 1, so that's where we want to tell the calculator to look for it. The L1 key is a second function on the number 1 key. So we're going to hit the second number 1, and then you'll notice that the X list now says 1, and we want the frequency set at 1. To get the calculator to draw the graph, hit zoom and the number 9 key, and now we have our histogram drawn by the calculator. Now let's take a look at this graph. If we were to draw a smooth curve over the top of this graph, we would see the shape of this graph would be unimodal and symmetric. The curve would represent the distribution, and in this case, we have a normal distribution. I want you to copy the graph from your calculator onto your notes. Go ahead and pause the video while you copy the graph onto your notes. Now that you have the graph in your notes, we need to take a look at a couple of other features of this data set in order to determine if it's normal. So in addition to the shape of the graph being unimodal and symmetric, We also have to have data that follows the 68, 95, 99.7 rule. So in order to find out if this data fits the rule, we have to know the mean and the standard deviation. Well, that's easy because we already have the data in the calculator. And the calculator will tell us the mean and standard deviation by hitting Stat, over to Calculate, and one variable data. You can see that the mean is approximately 16, and the standard deviation is approximately 1.2. Now, there's a whole lot of other decimals, but we don't have to worry about that. So here's what we want to know. We need to keep in mind that the mean plus or minus one standard deviation should be equal to 68% of the data. Well, how much would 68% of the data be? Well, we have 36 pieces. Remember, we had 36 pieces of data. We're going to multiply that times 0.68. And we'll do that with the calculator. And we end up with about 24 and a half. We'll just round that down to 24. 24 pieces of data have to be in the first standard deviation. Well, let's see if it is. Well, what was the standard deviation? Remember, the mean, and we're going to go ahead and write this down, the mean is equal to 15.8, or you could use 16 if you want. I'm going to use 15.8, and the standard deviation of the sample is 1.2. So if we were to draw this graph, if we were to draw a normal distribution, (15.8) would be right in the middle. And then we would add and subtract. First add, then subtract 1.2 to get these next values. So 15.8 plus 1.2 is 17. And 15.8 minus 1.2 is 14.6. So now what we want to do is we want to see if 24 pieces of data fall between these two values. Well, how can we do that? Well, the only way we're going to be able to do that is to count. So luckily the data is already in order. So 14.6. 14.6 starts right here in the data set. Where does 17 stop? 17 stops right there. Let's count and see if we have our 24 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 24 pieces of data that falls in the first standard deviation. But that's not enough. We also have to have 95% of our data fall within 2 standard deviations. Well, where would 2 standard deviations be? Well, 2 standard deviations would be another 1.2 above 17, so it'd be 18.2, and below 14.6. So it'd be 13.2. So now we want to see if 95% of our data fall between 13.2, which is going to be right there, and 18.2, which is right there. It's all but 2 pieces. So how much is 95% of 36? You take 95.95, multiply it by 36, you get 34.2 pieces of data. Well, we have 34 pieces of data, so close enough. And then the remaining 2 pieces of data take it up to our 99.7%. So if we had a lot more data, then we could check for 3 standard deviations, and that would have to be at least 99.7%. In this case, it's going to be 100%, which is good enough. All right. So for assessing normality, not only does your data have to follow a normal distribution, so that's 1, follows normal distribution, but it also must follow the 68, 95, 99.7% rule. The last thing that we're going to look at is a normal probability plot. We're going to take because this would be a whole lot of work if we had to do this every single time that we wanted to check to see if a distribution was normal. And so there is a better way. And the better way is with another graph on our calculator. So if you clear the home screen, you go back to your stat plot and back into your first set of screens, you'll see this graph all the way at the end. So we arrow down, arrow to the right, and hit enter, and that will highlight that graph. Now your data list should still be in list 1 because that's where we put it. You want your x-axis on the data axis. So pause this while you set up your screen just like mine. Now that your screen is set up just like mine, if you hit zoom 9, you'll see a scatter plot where the scatter of the data is in a straight line. When your data is in a straight line, you know that your original data was normally distributed. This is not a scatter plot. It is a different kind of plot called a normal probability plot. So when you draw this plot, you'll actually get one of 3 different things. You could get a plot that looks like this one, where it's linear, which would mean the data is normal. So if your data looks like this, the data is normal. If your data looks curved, then it depends on which way it's curved will determine what you have. If you have a data pattern that looks like that it's curved upward, then this would indicate that the original data was skewed, and it was skewed to the right. And you probably guessed that if it is curved the other way, if your data looks similar to this curve, then the data would be skewed to the left. Now, what I want you to do is sketch a normal probability plot that you think would be strongly skewed left. If you drew any set of data where the data was skewed way up quickly, then you would be right. That data is skewed left. Well, that's all for today. See you next time.